with 10.7, we're solving, still working with radicals, but this time we're going to be solving radical equations. And really, for almost everything that's here, basically there's two things you're going to do when it comes down to this. If you only have one radical, you're going to get the radical by itself on one side of the equation. And once you get the radical on one cell, on all by itself on one side of the equation, maybe a little bit double redundant there, but that's fine. It's like having a hot water heater. Why do you need a hot water heater? You already have hot water. Okay, anyway. After you do that, then you just square both sides. Now, I have to kind of say this, if it's a square root. If it was a third root, then we would take everything to the third power. If it was a fourth root, you would take everything to the fourth power. Whatever the index is, that's what you raise both sides to when it comes down to it. Now, I think everything that we're doing here in 10.7, everything is all square roots. So basically, we're going to be squaring everything down, do all the parts that's here. Okay, so all the stuff that's here, that's pretty much the whole thing that you're going to do. The one thing you have to kind of check for on this one. You cannot have square root of a variable, whatever it is. Doesn't matter if it's x, y, m, z, t, whatever. You cannot have the square root of some variable, some expression, equal to a negative number. Because basically, it's one of those little, if you try taking the square root of a number on a calculator, you know, it gives you the error message. This one's kind of that same thing. That it's kind of working that part around, so they're always going to assume that the number you're going to take the square root of should be a positive. There's some other little details that get a little sticky with it, but for now, that's the only thing you have to worry about when you're going through this. Okay. And they're going to start off really small with objectives, and then they're just going to build up just a little bit of time on these. So they're going to start you off with something like this, where you have square root of x equal to 3. Okay, so we've already got the square root by itself over here, so all you're going to do is you're going to take both sides of this equation and raise it to the second power. And if you square root a square, or you square a square root, then basically everything cancels out and leaves you with whatever you have on the inside, which is the radicand. 3 squared is 9. And you get x equals 9. Okay, and then just real quick on this one. If they give you like square root of t equals -7. That one you get no solution. Okay, now, and here's kind of, if you want more of the details on that one, maybe you're not. But it's basically going back and talking about it. If you square a number, how you have to have the square and the square root work up. They go back and kind of dig in some details on that one. So, actually, on second thought, let's just kind of skip it going. We can dig into it, but sometimes, you know, the details can kind of dig you down a little bit. So, okay, so objective 2. Here's where they actually make you do a little bit of work. Okay, we're going to have -2 plus w plus 9 equals 5. Okay, so same thing we did before. We're going to get the square root all by itself, so we're keeping this part. We're keeping this over here. We've got to get rid of a -2. So since it's negative 2 plus this, to fix that, we're going to add 2 to both sides. And then we have square root of w plus 9 equals 7. And once you've got the square root all by itself over here now, then we're going to go back and square both sides. So we'll square the left side, and we'll square the right side. Okay, and when you square the square root, again, those two things cancel out. Leaves you with a w plus 9. 7 squared is 49. And then from there, just solve out this regular equation, subtract 9. Your w would equal 4. Okay. Now, one small thing they might have you do along the way, which really shouldn't be an issue for anything we're doing just yet. We'll show you when this pops up. They may tell you to check your work. And honestly, on these, as long as the numbers are fine, as long as we've got the one square root, as long as this square root doesn't equal a negative number, you know, if you'd gotten here and this had been a negative 7, then you go ahead and do no solution. But as long as this number is working, if you go through on one of these, the number should check out. But if you wanted to make sure, this is where you can always take this number back here and plug it back in and actually make sure that it works out to be what it is. So if you ever want to check the answer just to make sure, you can always go back, take this number, plug it back in the original, and make sure it works out. If you do the negative numbers, that's one of those that if you actually went through and solved that problem, you would get an answer that seems like it would fit. But then if you went back and plugged it back in the original equation, it actually would not fit. So that's why the negative number, it always gives you what they call an extraneous solution. It's one of those solutions that it looks like it works, but then when you check it, it doesn't. So it's kind of one of those things. Did we talk about extraneous solutions? We didn't? Okay. I thought we had. Okay. And a lot of these, the objectives are all really similar on these. So we're not going to do a bunch of different ones because they're just the same thing kind of repeated on these. We may do a couple of these where we'll do 2. So for this one, let's do square root of 3v minus 8 equals 5. Okay, square root's already by itself, so we're going to square both sides. Again, when you square a square root, everything cancels out. That leaves you with a 3v minus 8. When you do 5 squared, that's 25. And now you're just solving a regular equation. So from here, we'll add 8 to both sides. And divide by 3, so then we get v equals 11. The only one you have to be just a little bit careful of, and it's not really bad, sometimes people jump the gun on it a little bit, is where you get something like this, where you have 1 equals the square root of 3y minus 9 minus 2. Because some people automatically see that negative number and they go, wait, we got a negative number, that's not going to work. But remember, you've got to get this square root by itself, so before you do anything, you're going to add this 2, got to get rid of it, and move it over here. So now it's 1 plus 2. So you get 3 equals the square root of 3y minus 9. So that now when you move that negative 2 over, it turns it into a positive 2, and now we're good to go because it's there. Now, if you'd gotten here and this had been, negative 3, that's when you would say no solution. But again, because it was a negative 2 here, once we move it over, now it's positive. So now we can go back in and square both sides. All right, 3 squared is 9. Again, the square and square root cancel. Add 9 to both sides. And divide by the 3, so then y would equal 6. Okay, so up to that point, everything's good. We're rolling along. When you get to objective 4, we're still solving equations. We're still going to go through and do all the same steps. Here's what changes when we get to variable 4, objective 4. This one you're going to have 2 radicals. Alright, and on this one, when you get the 2 radicals, basically what you're going to do is you're going to separate the radicals so you can put one on the left side, one on the right side. So just separate it so you got one on the left side of the equation and then one on the right side of the equation. Okay, now once you do that, you're still going to go ahead and square both sides. Okay, now, and if you have 2 radicals, this is one where sometimes you may get one of those solutions that may look really good, but it may not actually work. So when you have the 2 radicals, you want to check your solution just to make sure that it works. So sometimes you'll get an answer, but it may not actually be an answer that works, so you do have to go back through and check it just to make sure it actually does make sense. Alright, so here we go. We'll start you off with one already got them separated, and then we'll do the next one with that. So let's do 8x minus 15 on one side, and then let's do 6x minus 3 on the other side. Okay, so they're already separated, so we're good to go there. We'll square both sides. Okay, and when you square both sides, because they're both square roots, everything's going to be gone. You're left with 8x minus 15 on the left and then 6x minus 3 on the right side. And from there, it's just a regular equation. You're going to get your x's to one side. Get your numbers to the other side. And divide those two numbers so you get x equals 6. Okay, now, and when you check it, when you go back and make sure that the answer does fit for what it's worth, when you plug this number back into the original problem, basically the squares need to be positive. Your radicand, the number that's on the inside, has to be positive. If it's negative, that's going to be one of those numbers where, okay, it looks like it's good, but when you check it, it actually is not. So that's really what we're going to do back on this part. So if you take the 6, and again, the original problem that we had was square root of 8x minus 15 equal to the square root of 6x minus 3. As long as we plug this 6 back in here, and here, as long as both of these numbers are positive, then we're good to go. 8 times 6 is 48 minus 15. That's square root of 33. So we're good to go there. And again, if it works out, the right side should also be square root of 33. Do 6 times 6, that's 36 minus 3, which is 33. So we're checked out. We get the same answer. They're both positive on both sides. So then we're good to go. Okay, the only other thing they can really do with the 2 radicals, there's really only one or two cases that can be. It'll be something like this, where that you have the 2 parts together, where you got one radical minus the other radical. Okay. And to separate those two, so you get one on one side, one on the other, all you're going to do is just take this one that's negative and just add it to both sides. Okay, so that'll leave you with the square root of 9x minus 8 on the left, and then we'll make that a 6x minus 2 on the right-hand side. And let's rewrite that so you can actually read that part. Okay, you've got the two radicals on both sides. And then here's where if you want to start shortcutting a little bit, you're going to square both sides. But again, when we square both sides, the square roots are gone. So it's going to leave you with a 9x minus 8 equal to 6x minus 2. Get the x's to one side. And then if we move the 6x's over here, we're going to move that 8 over to here. Negative 2 plus 8 will make that 6. So if 3x equals 6, then we get x equals 2. Okay, and again, more than likely, even with the two radicals, more than likely that should be an okay answer. Again, if we just check it real quick, it's square root of 9x minus 8. That was equal to 6x minus 2. Plugging in 2 real quick. This one's fine because that's the square root of 18 minus 8. Plug the 2 in here. It's the square root of 12 minus 2. Both of those come out to square root of 10, so we're good to go. Okay, no negatives, so everything is good there. Okay, last objective that's in 10.7. This is the one that might give you a few problems along the way. And here, this one, when you see this one, it kind of jumps out at you. Hopefully. We get x equals square root of 3x plus 28. Okay, when we got the square root by itself, we already got it here. What's the big difference between that one and all the other problems we were doing? What was this number that was over here on the side? Or what was the expression? Sorry. It was just a number, right? It was 4, it was 5, it was 6, it was 7. If this is x, well, we're still going to go ahead and do the same things. We're still going to go ahead and square both sides. So we've got this. So you've got x squared, which doesn't do anything other than just leave you with x squared. The square and square root do cancel each other out. That leaves you with 3x plus 28. Okay, now here's the big difference is now it's not just x, it's x squared. So for those problems when you get x squared here, you're going to have to move everything all to one side. And it works better if x squared is positive. So let's move this 3x over here. And at the same time, let's go ahead and move that 28 over as well so that we move everything over to the left-hand side. Okay, so now we're here. It's x squared, so how many answers are we looking for? 2, right? So guess what we do to find those 2 answers? Everybody's favorite thing. It's the F word, right? Factor. Yay! Everybody gets to factor. You thought you were done, but no, here it is again. Okay, so you got to factor this thing off. So now you're looking for the factors. Now, luckily on this one is they're probably going to give you easy factoring, so it's not going to get super hard. It's the factors of negative 28, where the sum is going to equal negative 3. Okay, and this is kind of good because we're getting fairly close to the end of everything here. So if you go through the factors of 28, it's 1 and 28, it's 2 and 14, or it's 4 and 7. Hopefully you're jumping out saying, well, it's got to be the 4 and 7. And just remember, because it's a negative 3 here, that sign always goes with the bigger number. And if you do a negative divided by negative, it makes the other number a positive. Okay, so it's got to be the plus 4 and the minus 7. Okay, so you get x plus 4, x minus 7 equals 0. And remember, we are solving, we're trying to find what x is. So that's where you take each parentheses and then separate each parentheses out and then solve that parentheses. This one will subtract 4 to make it negative 4. This one will add 7, so we get x equals 7. Okay, now, and again, we're going to not solid this thing in, not going to leave it with some gaps, because you do have to check these numbers, and if you get two answers, there's a really, really, really good chance that one of them is going to work and one of them is not going to work. It may be that both of them work. It may be that neither one of them work. This is one where you don't really know until you go back and check it. So you do have to check both answers. Okay, and we started off with Alright, let's check the negative 4 first. I'm going to plug it in here, and we're going to plug it in here. Okay. Can the square root equal a negative number? Can't, because we said if we're going to square root it, this number always needs to be positive. So as soon as you plug in this negative number over here, you get negative 4 equals, this would be negative 12 plus 28, which would be 16. But if you take the square of 16, that should be a positive 4, not a negative 4, so that one's not going to work. So same thing with this one. That one doesn't work. Alright, now if we check the 7, you should see something a little bit different happen here. Get 7, plug it in here, see what happens. So we get 7 equals square root of 3 times 7, which would be 21. And 7 does equal the square root of 49, so that one's okay. So the one answer that works here is going to be x equals 7. Okay, so on all these that we're going through, again, if you, and that's really when you want to get that. When you have that square root of the number equal to an x over here, that's really when you want to check those. The one where you have the two radicals, and you might find a weird one that will happen, but more than likely on those, it's going to be when you have that x that's over beside it. All right, let's do one more of those. Okay, same thing. You've already got the square root by itself, so we can go ahead and square both sides. Yeah, and on the left-hand side, you're going to get v squared equals 7v minus 10 on the right-hand side. Okay, and again, if you get the v squared, pull everything over to one side, so we're going to take that negative 7v, we'll subtract it over here. You've got the minus 10, and we'll add 10, move it over here. We have v squared minus 7v plus 10 equals 0. Alright, again, when you bring it all to this side, you're going to have to factor. So we're going to find the factors of positive 10, where the sum would equal negative 7. Right. And again, they shouldn't give you two awfully big numbers. It should be something fairly easy to work through on these. It is a -7, so again, the bigger number has to be negative. If you do a positive odd by negative, that means the other number is also going to be a negative. So that would be the v minus 2 and the v minus 5. Okay, set them both equal to 0. So v equals 2. And v equals 5. Okay, now in this case, they both came out positive, so it may be that we might actually get two answers, because if it was negative, when you plug it back in the original, you're going to get a negative number over here, so that's automatically going to kick that answer out. This one's positive, so we've just got to check and make sure that they both work, because right now it looks good. So again, we're going to check both answers. Okay, so it was 7v minus 10. We're going to plug in the 2. There's 2 equal the square root of 7 times 2 minus 10. Is 2 equal to square root of 4? Looks like it does, right? Square root of 4 would be 2, so that one's okay. So v equals 2 is good. Okay, and we'll do the same thing with this one. We'll check the 5. 7v minus 10. So it's 5 equal 7 square root of, try it again. So it's 5 equal 35 minus 10. So it's 5 equal to the square root of 25. That also checks. So both answers work. So then you'd actually get two solutions that 2 works and the 5 also works it. Okay, so one solution maybe, two solutions. Now, it could be that you may check both and neither one worked. If neither one worked, then it's no solution. Probably not going to happen, but it is a possibility when you go through some of these, start working through everything.